Alright, this is our side lesson for our Pre-Calc 11 class. This lesson is on simplifying square roots using geometric representations. And I apologize ahead of time, one, I'm wearing a flamingo shirt, and two, these slides aren't the same format as the rest of our lessons. So, still good content, so let's get through this with a flamingo shirt. So, when we simplify square roots, we often learn it using algebra or factoring techniques. What we're going to do right now is work on our conceptual understanding of what it means to simplify a square root and how these different representations connect. And so I like to say there's two ways to learn a math concept. There's the conceptual understanding way that usually takes more time, but if you put the time in, you have a deeper understanding of how something works. The second way of learning a math concept is what I call the black magic way. And usually there's like a formula or like just do these steps and it works kind of a thing. You don't really understand it very well, but you can do it a lot quicker. What we're going to do right now is stop doing black magic, simplifying radicals, and spend some time working on conceptual understanding. So, start, we're going to say this right here is a square. And the square has an area of 1, represented by the number 1 inside of it. If I have a square with an area of 1, that means its side length is 1. And we can relate the area of a square and its side length using the operation of square roots. I mean, the name square is in the name square root, right? So we can say our relationship is that the square root of the area of a square is its side length. And so with this square, we can conclude that the square root of 1, the area, is equal to 1, the side length. Quite boring, but hang with me, we'll get more exciting. We can put 4 of those squares together and get a square with an area of 4. It's 2 tall and 2 wide, so the side length is 2. We could put more squares together and get a 3 by 3 block, so 9 blocks makes an area of 9, side length of 3. So then we can conclude that the square root of 4 is 2, and the square root of 9 is 3. For that reason, the square root of the area of a square is equal to its side length. And we can fill in the first 100 square roots. We can fill in 10 of them just using those, what I'm going to call 1 blocks. But so we can make a 4 by 4 with 1 blocks. So it'd be 4 tall, 4 wide, and it'd be an area of 16. You can make a 5 by 5 with 1 block, so 6 by 6, 7 by 7, and 8 by 8. 9 by 9 would have an area, a square with an area of 81, and then a 10 by 10. And we could draw those blocks out and show that they have those areas. I don't want to draw a 10 by 10 right now, sorry. Alright, how about the rest of those squares? So up to this point, maybe you've seen those examples before, but how do I represent the square root of 2 and the square root of 3 and so on using a square? Well, instead of looking with a square with an area of 1, let's look at a square that has an area of 2. By our definition of square roots, the square root of the area would be its side length by the definition. So that we can say the side length of this square is the square root of 2, which by itself isn't super exciting because now we know that the square root of 2 is equal to the square root of 2, or the square root of the area is, itself. It's not really an exciting example, but stay with me, it gets more exciting. And this is the biggest learning curve right here in this lesson, so pay attention closely. Excuse me, drink of water. Alright, here we go. So, if the square root of the area is its side length, then the square root of 2 is the square root of 2. However, if I take 4 of those blocks and I put them together, I now have a square with an area of 8. 2 plus 2 plus 2 plus 2. If I look at the side length, well, one of those blocks is the side length of the square root of 2. So the side length of this square is the square root of 2 plus another square root of 2. Or we could just say 2 times the square root of 2. Because root 2 plus root 2 is 2 root 2. Just like x plus x is 2x. You know, same thing. Alright, so we can take more of those 2 blocks and put them together. See, we have a 3 by 3 with blocks. Those 9 blocks in this one. Each block is an area of 2. So 9 times 2, we have an area of 18 in this square. The side length would be root 2 plus root 2 plus root 2, or 3 root 2. So what we've just shown is using our definition, our geometric definition of square roots. The square root of 2 is the square root of 2. The square root of 8 is equal to 2 root 2. And the square root of 18 is 3 root 2. And that's the biggest mental jump in this lesson right there. If that made 100% crystal clear sense, then the rest of this lesson will be fun. Otherwise, keep working at it. You got this. Okay, so we can add those to our roots chart. How about these root blocks? Well, the 4 by 4 of 2 blocks would be 16 blocks times 2 for each block's area would be 32. So the area of 32. It's 4 tall and 4 wide, so the square root of 32 would be 4 root 2. Then we have 5 root 2 and 6 root 2 as well. We can also do 7 root 2. But if we go any higher than 7 root 2, if like we do an 8 by 8 block, we're going to get an area that's greater than 100. So we're not going to worry about those ones now. We're only going up to 100. We can add these root 2 side lengths to our roots chart. Now, the next open box in our roots chart, if we start at 1 and work our way up, is the square root of 3. We did 1 block, so we did 2 blocks. Now we're going to do 3 blocks. So we can use these squares to figure out 3 blocks. So if you have a square with an area of 3, the side length is the square root of 3. So we know the square root of 3 is the square root of 3. It can't be simplified. But if I put 4 of them together, I get a square with an area of 12. Side length is 2 root 3 plus root 3. So the square root of 12 is 2 root 3. And we can keep going. Area 27, so 3 root 3. Area 48, so 4 root 3. Area of 75, 5 root 3, and so on. We could do, we have 3 blocks added in there. We're not going to do 4 blocks because we already simplified the square root of 4. If we try doing 4 blocks, we could, but we're not going to find anything new. If I put 4 blocks together, I'm going to get 16, and we already have 16. And if I keep going, I'm not going to get any new radicals that we don't already have solved. So what we're going to do is we're going to skip to the next available block, which is the square root of 5. Haven't done that one yet, so next we'll do 5 blocks. We can figure out all of our root 5s. Next blocks would be 6 blocks. So we can figure those ones out. And we're just keep going in that pattern. 7 blocks is next, 10 blocks, add those. 11 and 13 blocks are the next ones. Those, 14 and 15 blocks. And if I'm going too fast, feel free to pause the video and go back and work through some of these and just make sure they make sense. Because remember, grades are dependent on how well you know what your teacher wants from you. But learning is the result of you going back and spending time making sure you understand what's going on. And I can't force you to do that, but I can remind you, pause the video, go back and look at some of these and make sure they make sense to you. We could do 21, 22, and 23 blocks, and then 26 blocks. We could do a 2 by 2 with 26 blocks, but then anything greater than that will get us over 100. So what we know is yeah, because like 4 blocks with 26 is over 100. And so any of these other unsolved or unsimplified roots, if I put them in a 4 by or 2 by 2, they're also going to be greater than 100. So the rest of these radicals cannot be simplified. All these purple ones right here. So we're just going to fill those in. That's that. All right. So now let's take a look at simplifying a square root with the geometric representation, and we'll juxtapose it with an algebraic representation, and we'll see if we can find some patterns. Notice the way we've done it before, or the way I like to explain it, is we're dividing out what's the biggest perfect square we can divide 20 by. What we're trying to do with that, connecting to the geometric representation, is we're saying, okay, 4 is a 2 by 2 square, so 2 blocks by 2 blocks wide, 2 blocks tall. Can we make, by dividing it by 4, we're saying, can we make a 4 blocks into a square with this area? When you divide by 4, you're left with 5. So the answer is yes, yes we can. It'd be 4 blocks, 2 by 2, and each block has an area of 5, that remainder. So 2 root 5, we have 2 by 2 square with 5 blocks, and that makes an area of 20. So the square root of 20 is 2 root 5. When we're actually going about solving these, we're going to, let's see here, yeah, there's some patterns there. I'll leave you to discover those patterns on your own, however you want to word those. When I work with simplifying larger square roots, I'm thinking, okay, what is the biggest perfect square I can divide this radicand by? 120. Perfect squares are any, like, 2 times 2 is 4, 3 times 3 is 9, so 4 and 9 are perfect squares, 16, 25, and so on. 120, I know a quick trick, you just take that number, divide it by 2, here's black magic for you. Divide it by 2, and that's kind of where you want to start when you divide it by perfect squares. The reason behind dividing by 2 is I know if I divide by anything bigger, it's going to give me a number smaller than 2, and it's probably going to be a decimal. So if I start with about 64, 49, and start dividing 120 by these perfect squares, and if I get a decimal, I just try the next one. Eventually I'm going to find out the biggest perfect square I can divide 120 by without getting a decimal is going to be 4. So what that tells me is when I divide 120 by 4, I get 30. So that tells me that I'm using 4 blocks, so a 2 by 2, and each block has an area of 30. So the square root of 120 would be 2 root 30 for that reason. Now I may, when I'm solving radicals, I may think about the square. Probably not going to draw it every time. Hence my thought bubble right here. I'm going to figure out that 120 divided by 4 is 30. I'm going to write root 40 times root 30, and then simplify the square root of 4. That's probably going to be the work that I actually show. Let's do that. One more example. So if I do 112, trying to simplify that square root, divide it by 2, it's a little less than 60, so I'll start around 49, you get decimal, 36 decimal, 25 decimal. If I take 112 and divide it by 16, I get 7, so that's the biggest perfect square I can divide by. So then I know I'm working with 16 blocks, so 4 by 4, you get 16 blocks, and each block has an area of 7. So then the square root of 112, so 4 by 4, so 4 root 7 is our answer. And we're going to stop that right there. Hope this helped you get a better conceptual understanding of square roots and how to simplify them. In future lessons, we're going to build on our understanding of square roots and radicals in general. So it's good to have a firm foundation.